Today let's see the program for generating permutations. Let's see what exactly the problem is, right? Permutation generation. So assume that you have got a input word to your program and you want to generate the different permutations of that word. So if the input word is going to contain a letter, say A, just a single letter, then the permutations possible for that word is only the same letter, which is A, right? Let's say the input word is going to contain two letters, A, B. So the permutations of AB are like AB, comma, BA. So as one more example, if the word is going to contain three letters, right, A, B, and C, so the permutations are what you see here: A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. Right? And the same can be generated if the input word is made up of numerical characters as well, right? 0, 1, 2, you can see the 6 possible permutations that you could get. So basically, we can see the pattern that if a word is made up of n letters, the total possible permutations are n factorial. So also in this case, the permutations are generated in lexicographic order. So what I mean by lexicographic order is they are arranged in their natural ordering of their occurrence. In terms of English, if the input word, the letters are arranged in the alphabetical order, the permutations are generated accordingly. Right? So that is what we mean by permutations generated in lexicographic order. So let us look at basically our program is to write code which takes an input word and generate all possible permutations of that input word. So let's first get some idea for how to generate it. Right? And I found it little difficult in the beginning. So let me go from the simple steps. So let's start with small cases, right? So most of the problems are easily attacked when you start with small cases and define how the problem and the solution would behave for a small case. If the word is made up of, say, one letter, like we discussed before, then the permutation is the letter itself. Let's say if the word is made up of two letters, this also we saw the two possible permutations are AB and BA. Now, let's take a deep look at how the permutations of AB can be seen as. So, the permutations of AB can be seen as the first letter of the word, right? The word is AB. So now what we do is we take the first letter of this word, right, which is A, plus permute it with the rest of the word, right? So when I say plus, you can think of it as a string concatenation operation here. So we take the first letter of the word and permute the first letter of the word with the concatenation operation of the permutations of the rest of the word, and the second letter of the word concatenated with the permutations of the rest of the word will give you the permutations of the word A and B. So let us see in a bigger example, this is reflected in a much more easy to understand way. If you look at the permutations of A, B, C, it can be generated as follows, right? So take the first letter of the word, right? So A is the first letter of the word. So the possible permutations of A, B, C are A concatenated with the permutations of B and C. So this will be one set of permutations. Then take the second letter of the word. So B permuted with the rest of the word. So if B is taken, the rest of the word is A and C. So B concatenated with the permutations of A and C. And finally, okay, I should have put a comma here, but it's a comma. Finally, C concatenated with the permutations of A and B. So these three things, right? So A concatenated with permutation of the rest of the word, the same for the second letter of the word, and same for the third letter of the word will yield all the permutations of the input word. Now, how can we get the permutations? So now we are defining the problem in terms of itself. So in order to generate the permutations of the big input word ABC, we define that okay, the permutations of ABC is equal to this particular thing, where we are telling it is each letter of the word plus the permutations of the rest of the word. So the same problem of generating the permutations in this step is reduced to a problem of smaller size. So generating permutations of ABC is reduced to the problem of generating permutations for a smaller problem of size which is one less than the main problem. Now, how can we deduce the permutations of this? So, permutations of B and C in the first term. So, whatever we define here will apply for the second and the third. But the permutations of B and C can be generated recursively. How? Take the first B, take the first letter of the word, right? BC, take the first letter of the word B plus permutation of C. And the other permutation is C concatenated with the permutation of the rest of the word, which is permutation of B. Now we reach the base case, right? So what did the base case say? If the word is made up of one letter, then the permutation is the letter itself. So now what happens? Look at this one. So C is one letter word, B is one letter word. So B plus permutation of C and C plus permutation of B will be nothing plus B plus C comma C plus B, which is nothing but BC comma CB. Now, so A plus permutations of BC is A plus the generated permutations of BC, which is what we see here, right? Which is ABC and ACB. In the same way, B plus permutations of rest of the word will give you the two more permutations. And finally, C plus permutations of AB will give you the permutation CAB and CBA. Now, these are the 6 permutations that are possible for the input word A, B and C. Right? So here we saw the problem defined in a very recursive manner, right? So now let us look at here we have seen the problem defined in a recursive manner, right? So we will see a recursive call tree, right? So let's assume that we call the permute function with the input string, right? It could be a word of length n, and in our example it was ABC. So let's assume that we call the function with the input ABC, and then how the recursive tree. So recursive tree is a nice way to visualize how actually the recursion folds and unfolds, right? So we call the permute function giving the input of ABC, saying that, okay, generate me all the permutations of the input word, which is made up of 3 letters A, B and C. And as we saw before, so we take the first word, right? We take the first word A and call the recursive function now with the input BC, right? So we take the first letter of the word A and then we call the same recursive function, but this time instead of passing ABC, which was the original input, we pass the rest of the word other than the character we kept aside, right, which was A. So the rest of the letters of the original word was BC and the function is called on that input. Now with BC, again the length of the input is greater than 1. So we call it again recursively, but this time the first letter of the word BC is B. So we keep the letter B aside and call the function recursively with C. Now when you get here in the recursive call to the permute function with the input word C, we reach the base case. So with one word, the permutation of with one letter in a word, the permutation is itself. So when the permute function is called with the word containing one letter C, so what is returned back is C itself. So now B plus C happens, right? So it's BC. Now keeping B, so we permuted the combinations of, we permuted B to be concatenated with the permutation of C. Now we keep C as constant and call the permute function with the rest of the word of BC, with the rest of the letters of the word BC, which is nothing but B now. And when the permute function is called with the word containing one letter B, so what is returned back is B, and C and B joins to form CB. So now the call to the recursive function BC made further two recursive calls which gave C and B, which was appropriately concatenated to B and C on the other side, yielding BC and CB, which goes above, right? A concatenated with BC and CB. So this one recursive call tree will be repeated for every letter in the main word. So now this recursive call tree, we did it for A. So now two more trees will be spun because there are two more letters in this original word. So with B, the rest of the word is AC now, right? So the rest of the letters that make up the word is AC. And again we call, so it returns CAC, and with C it returns A, so CA, so B plus AC and CA. And third, with CS constant, we call the permute function for the word AB, which again calls with A as constant calls for B, and with B as constant calls for A, and thereby returns AB and BA. So C plus AB and BA. Finally, we get all the permutations of the input string ABC, ACB, BAC, BCA, CAB, and CBA in the lexicographic order. So this is how we can visualize a recursive call tree for permutation generation. Now, with this idea in mind, let's go to the code and understand how actually we implement this in the code, right? So that it becomes little easy. So let's go to the code, right? Okay. So let's look at the permutation program. So what we take in the permutation program is the input string we take. So the input string that you want to permute for is ABC, right? So taking this input string, so we will call the permute function. So this permute function will return as a list. So as we saw, an input will give you a list of um, permutations of the input string. So this permute function is going to return an array list of string, but we will pass this input ABC as input to this permute function. So let's go and look at this permute function. So what exactly this function is doing, right? Okay. So this permute function is quite easy to understand if we keep in mind our recursive call tree, right? So this is the input word that is passed to this recursive function permute. So if this word's length is 1, right, if the word is made up of only one letter, we just add that word to the list and then return it. It's the base case, right? Else, let's say if the word length is not equal to 1, it's having more than one character, we start looping it. And you can imagine it from the recursive call tree. For each word, A permuted with the rest of the letters of the word, then B, then C. So for each word in the list, we need to loop through it. And whatever is that particular word that we are iterating through in the input word becomes that whatever is the letter that we are iterating through in the input word becomes the append character. So in the first iteration, the letter in the 0th position, right? So A becomes the append character, right? And in the second iteration, B, etc., etc. Now, what is the permute string, right? So what is the permute? So it's the which is reduced by forming a word which is created by combining the letters of the word other than the append character. So how can we do that? Yeah, simple substring operation. You can think of this as a prefix, right? So from the beginning, from the 0th position of the word, just before the ith word, and from the I plus 1, from the next letter of the word, till the end of the word. So what we are excluding, so you will know the substring operation starts from start till end minus 1, right? So here we start from n plus 1. So actually what we are leaving is the ith letter. So that is what we want. We want to form the permute string which is excluding the current letter which we want to append with the rest of the permutations, right? So that is what is the append character is, and that is what is the permute string is. Then what we do, we simply call the permute function in a recursive manner with the permute string that we formed, and whatever is getting written from this function, we return that by appending the append character with each from the permutation string of the smaller input, right? So that way, finally, when we return from here, we will return all the possible permutations of the input word that we got, right? So let's run this program for the input ABC, right? So when we do that, right? So we just do the program execution, and we know that the word was ABC, right? So what we get is, so ABC, ACB, BAC, BCA, CAB, and CBA, right? So here we can change the input as well, right? So I can change 0, 1, 2, 3, 4, right? So I'm making a word with 1, 2, 3, 4, 5. So the number of permutations that I should be getting for a 5-letter word is 5 factorial, right? So 5 factorial is 5, 4, 3, 2, 1. We should be like 5 was 20, 26, or 120. So 120 should be the number of permutations that I should be getting, and all the 120 should be arranged in lexicographic order of the numeric string, right? So let's give it a minute and the program will recompile, and then let's execute it. So now the program should execute, and I think it has generated all the 120 permutations that we were expecting. So the first permutation, so it has generated 120 permutations, with the first permutation being the ascending order of the string 0, 1, 2, 3, 4, and the last of the permutation should be the same string in descending order, which should be like 4, 3, 2, 1, 0. So it has generated all the 120 permutations of the word. So I hope this was an interesting problem. It was a little bit difficult for me to formulate it recursively to solve it, but I think this program can be improved a lot, right? So if you look at it, we are creating a list in every recursive call and then returning it by concatenating that particular word with the rest of the permutations of the uh, word, right? So I know that this program can be optimized better in terms of the memory usage, but I hope like I will optimize the program and meet you in an improvised version of the permutation generation shortly. Thank you for watching the video.